Hello, this is a video response to a question on the Sudoku subreddit asking how to do chaining without keeping track of notation. Um, and I started to write out an answer to this because I do chaining without keeping track of any kind of notation, but it was turning out to be a lot to type. And so this will probably be a lot easier for both of us if I do it here in a video. So I'm going to put a link to this exact Sudoku board in this app down in the description. So open it up and go to this help menu, find the chains down here, and let's start with the first one. And I'll just walk you through how I do it in case that's helpful. So we're going to do two kinds of chains, type 1 and type 2 alternating inference chains. And we'll get more advanced as we go. So we'll start easy here. This is also known as a two-string kite. So the logic here is if this is not a 2, then that is a 2 because one of them has to be because the column needs to have a 2 in it somewhere. And if this is a 2, that's not a 2, and if that's not a 2, then this is a 2, right? Because if that was a 2, it can't be another one in the block, and then there has to be one in the row. So you end up here. So the two ends of the chain are the only important things to keep track of. You don't have to remember any of the coloring or values in the middle, only the ends. And so if you can, I don't know, keep your finger here while you look around, and then you keep a finger there, or you just remember that you're looking at this last cell, that's good enough. Because the two ends of the chain say if this is not a 2, then this is a 2. And if you go travel the other way through the chain, you can see the opposite is also true. If that's not a 2, then this is a 2. And just a note on the representation here, the green lines mean you always start an end of the chain thinking if this is not a, in this case 2. And then the green line says it is something, and then the red line is not. The green line is. It always alternates like that. And so if you start and end a chain, if you start here and then you end up there saying something with the same value, so not a 2, and then you end with it is a 2, then you check the intersection of those, any cells that can see both ends of the chain so far. And there's a 2 there, so you can eliminate it. Because if that was a 2, then neither of those could be. And that's breaks the logic, right? We already said if it eliminated that one, it must be on that end. But this would eliminate both, so that cannot be. So you find any cells that can see both ends, eliminate the 2. So let's turn off the visualization. And let's just remember this one cell. We don't have to remember the rest. If that's not a 2, then this is a 2, which means that one is not a 2 because it's in the same block. And if that's not a 2, then this one is a 2 because it's the only other possibility in that row. And now we can check the intersection. There's an intersection here with our starting point. That doesn't help, but there's also an intersection here with our starting point, and that lets us eliminate the 2. So let's try it again, but with a longer chain, and we won't have to remember what's in the middle. So I'm going to start here, kind of go around this way just to speed things up. Okay, we'll turn that off. So if that's not a 1, it's a 9, which means that's not a 9, so it's a 2. Which means that's not a 2, so it's a 1. Which means that's not a 1. And if we look in the column, which means that is a 1. Not a 1, 1. Those are the only ones in the row, in the column. Okay, and now if we remember our starting point and where we got to here, we can check the intersections. Right there, no help. But here, yep, we can eliminate that 1 for the same reason as before. So there's the visualization, and I didn't have to keep track of anything in the middle. Now let's move on to a type 2 alternating inference chain, which is a bit different. Let's ignore the middle of the chain for now. And let's just remember that the green line shows that the ends of the chain show that if this is not a 2, then this is a 1. If this is not a 1, then that's a 2, because you can always travel a chain in either direction. So here the difference is that the two endpoints of the chain can see each other. They're both, in this case, in the same column. So that makes it a type 2. With a type 1, they have the same value. With a type 2, they can see each other. So as you're going through, well, let's see. Let's just look at this logic first of all. So let's consider both possibilities in the world. Either this cell is a 2 or it's not. If it is a 2, then it cannot be a 1. If it's not a 2, then it also cannot be a 1, because the chain shows us that this is a 1, eliminating that one. So either way, we can eliminate that 1. That's how this chain works. So more generally speaking, if two ends of a chain can see each other, then you can eliminate the value from one end. The value of one end is eliminated from the other end. So because the 1 is here, you can eliminate it from there. If there was a 2 here, you could eliminate it because of the chain. Okay, so I'm going to turn this off, and we're going to walk through the chain without remembering what's in the middle. If this is not a 2, then this is a 2, which means that's not a 2, which means this is a 2, which means that's not a 2, which means it's a 1. We have to get down, where were we, the bottom right, which means that's not a 1, which means that's a 1. There's the only other possibility in this row. And there we are. We started here. Now we're on a cell that can see our starting point. So we can eliminate, we started with not a 2 is a 1. So we can eliminate the 1 from here and the 2 from here. All right, one more time. Sure, let's go for this one. One moment. Excuse me. And I'm going to walk through this one step by step as if I'm still going to walk toward what I can now see as a solution, but at each step of the way I'll walk through what my process would be. So I'm going to start here, not a 1, kind of go around that way. Okay. If that's not a 1, and remember this starting point, not a 1. If that's not a 1, this is a 1, which means that's not a 1, making it a 2. Okay. Whenever you say a cell is something, you think about your endpoints. Now you've made a chain. Think about the endpoints to see if it does anything. Here we started there with 1, ended here with 2. They don't see each other. They're different values. Doesn't help. Okay. So let's keep going, which means that's not a 2, which means it's a 1. Okay. I just said it is something, so I'm going to check my endpoints. They don't see each other, but they are the same value. So we can check the intersections to see if it's a type 1 chain. That would mean we could eliminate 1 from here and there. Doesn't help. There's nothing to eliminate. Let's move on. Not a 1, 2. I just said a cell is something. Check the endpoints. They don't see each other. They're different values. Doesn't help. Not a 2, 9. Again, they don't see each other, different values. Let's move on. Not a 9, 1. Same value. So now we check the intersections. If this is not a 1, this is a 1. Okay, so let's see. Any cell that can see both ends, we can eliminate 1. That's this one, that one. Can see, all 3 of those cells can see both ends. None of them have a 1, so nothing to do there. But also these 3 cells. And here we see a 1. So if that's not a 1, this is a 1. If that's not a 1, this is a 1. This can see both of them. We can eliminate that 1. And that's how I do it. I hope that that's helpful. Let me know.